In this demonstration, we shall explore many of the preliminary conceptual design tools available in formz to articulate 3D spaces and use formz as an integral part of the design process. As a sample project, we will recreate some of the spaces of the St. Margaret of Cortona Church, located in Columbus, Ohio, designed by Pietro Bellucci. This will not only highlight the speed and ease of modeling in formz, but will also show off some of the many rendering, visualization, and animation capabilities. Let's get started. We begin by using any of the drawing tools in formz. Just draw the shape that we want on the XY plane and extrude it to the height that we need. We can add additional topological information by inserting points and segments and faces anywhere that we want on that existing geometry. And then to modify the shape, we can simply move those points and segments anywhere that we want to sort of sculpt and modify that 3D form. We can insert additional faces onto the object by using the Insert Face tool. We can move the reference plane grid as a guide if we want, and then just simply use the same drawing tools, and instead of creating a separate object, we can draw right on the face of an existing object. And then with that profile, we simply extrude that up, and that adds additional volume to that solid object. Let's move the grid to the other side, and we can type in numeric information, or we can just sort of freely use any of the drawing tools to create and draw on any part of that geometry to add additional volume. Now there's the two towers of our building. Maybe we'll go to a side view, and to create a slope on the towers, we can draw a vector line. And with that vector line, what we're going to do is use that as a trimming line. So using the trim tool, we can have that line cut through the solid object, just like a wire cutting through a piece of wood. Now to create the slope for the roof, what we'll do is insert a segment right in the middle. We'll use the object snaps to make sure we're snapping right to the midpoints of the existing towers that are there. And then just simply move the points down and create the actual slope. Now, we have disturbed the planarity of that face that's there, and that's not a problem because we can make it curved if we wanted, or in this case, we'll use the Extend tool and we'll highlight that face and extend it to this other face that we have drawn at the proper slope. So we can extend any segment or face to any other segment or face in our model. At this point, let's create the actual roof itself by using the derivative tools. We'll extrude a 1-foot slab off of the existing faces that are there, so we don't have to trace over any of our geometry. We can use the derivative tools and derive objects from the existing object that's already there. We can also create a 3D enclosure by simply clicking on the face, give it the wall width and thickness that we want, and now we have a nice little 4-inch frame. And there's the roof. Now let's go back to the original solid massing of the building, and what we'll do is take the single solid object that we have here, and we're going to delete just some of the faces of that. So we've actually converted that solid object into a paper-thin surface. Now if we want light to come inside the towers, we can take these faces and we can use the Separate tool to separate those so they become separate objects. And if these are glass panels, we can assign a transparent surface style color. And these are all paper thin surfaces, so we can use the Parallel tool, give it the offset thickness that we want, and convert that paper thin surface into a solid object of any thickness that we want. So we can convert from a solid to a surface, then back into a solid object. Next, we will move on to the front entrance of the building. We can create an opening by drawing on any face of the object, and if we were to extrude out, we could add volume, or we can push it through to subtract volume. Let's say you're the type of designer that would like to work with 2D information. formz can very easily handle that. We have a drafting environment. We can import stuff from other programs. We support over 30 different import-export formats, or you can just work with 2D information here inside of the modeling environment. And then just simply take that 2D information and extrude it into 3D geometry. We'll take the slab for the roof and move that up, and then maybe take some of the segments of the side wing walls that we extruded up and give that a little slope for the walls. As we move to the side, we're going to create a different space here by, instead of creating the outside volume and working our way in, we're going to start with the inside volume first. So we'll just create maybe a polygon pattern, type in values for the inside radius if we want, and for the overall height. And there's a transform tool, which allows us to move, rotate, and scale all with a single tool. So we'll move our space more closer to the side here and rotate it, scale it, reshape it, all with one single tool now. Let's change the shape of that by grabbing a face and pulling that out just a little bit and sculpting that area into the volume that we want. And then to add a roof, once again, we'll go back to our derivative tools, extrude a solid slab, and the 3D enclosure tool will then allow us to just simply click on that outside boundary edge and create a wall around the outside. Now, whether the geometry is created directly or created using the derivative tools, we do have access to the control parameters to further modify it later. So you can see here, I can graphically modify the wall thickness and height and shape of that geometry by graphically moving those controls, or we can query the parameters in which we can numerically edit all those same parameters that we were changing graphically. Now, to create an opening in the front and back, once again, we'll just use the insert hole tool. We'll draw the shape that we want, and we can have that not only extend through the existing wall, but we can have it go through multiple boundaries also. Next, we will put our building onto a 3D site plan. We can take contour line information that's either created in formz or brought in from any other program. And then we can take the contour lines that are there, and using the terrain modeling tool, we can take the contour line information and generate a 3D solid terrain model. Now, there's many different models that we can create. For example, we can do a stepped model, sort of like the layered cardboard. We can also do a triangulated contour model, which keeps all the contour lines fixed, and it just triangulates a surface in between each of the contour lines. And there's a mesh model that we can create at any mesh resolution. So we can make it 1 inch, 1 foot, 10 feet, 100 feet, so we can show as much detail as we want for that 3D terrain surface. We can map a series of surface style textures, such as a color gradient scale, to represent elevational heights. We can import drawing files and map those onto the 3D solid terrain. When we import those files, as we saw earlier, you can also take that imported data and extrude that into 3D geometry, besides mapping it onto the geometry that we have, as we show here. You can also import satellite or aerial photographs that are at a specific scale. You can map it right onto the accurate contour line data that we have there. And because this is a true 3D solid model, we can do things such as this. We can take a single flat plane, a transparent surface, and just sort of move that up and down to emulate the water level. Now, of course, you can animate in formz, so we can just simply take that plane and animate it moving up and down to emulate the water level at different stages. And the other advantage of this being true solid geometry is, let's say we want to work on a smaller section of our site. We can just create a solid volume, which represents a smaller section of the site. And then using the Boolean tools, we can do a Boolean split. And then we just simply move this other section down so we can work with a smaller section of our 3D solid site plan as we build the rest of the buildings on our 3D model.